Hey crazies, there's this thing that mathematicians and physicists like to say. Math is the language of the universe. You've probably heard it so many times that you've just accepted it as truth. But rule number 8 here at the Science Asylum is question everything. Is math really the language of the universe? Answering this question is going to take some time, and we need to be careful. So let's start with a simpler question. Is math even a language? What is a language anyway? That's 2 questions, but I'll see what I can do. We need to know what a language is before we can decide if math is one. A language is a complex system of words and symbols, either spoken or written, used by a particular community as a means of communication. Okay, so it makes sense why something like English, German, Arabic, or Iglatenpe would be languages. But what about math? Is math a complex system of words and symbols? Yes. Either spoken or written? Mostly written, but yes. Is it used by a particular community? Definitely yes. As a means of communication? Well, maybe. The purpose of math isn't just to communicate ideas to each other. Math is used as a tool to make predictions about the actual world. Of course, that requires us to also ask, is the sole purpose of a language to communicate? I would say no, and I think most of you would agree with me. Language can also be used as a tool. In the right hands, language can be used to inspire, or to lighten the mood, or to strengthen someone's resolve. In the wrong hands, it can be used to hurt someone, to destroy their reputation, instill fear, or even control others. So I don't think the fact that math is used as a tool is a disqualifier. The definition of a language doesn't even require that communication be the sole purpose. It said as a means of, not for the purpose of. I'm still not entirely convinced though. We need another test. Something else we know about languages is that you can translate between them. So if we can translate between math and something like English, then we might have a decent argument. Oh, you want to start an argument? Well, let me tell you. Not that kind of argument. When I say argument, I don't mean one of those fights over politics or whatever. An argument is more of a set of reasons or ideas in support of a conclusion in an effort to persuade others to the same conclusion. It's a point made by a logical individual in a calm discussion. People rarely think logically in political conversations. Anyway, let's give translation a try. When you translate from any language to another, some meanings can get lost. But as long as most of the ideas translate, I think we're good. We said earlier that languages are made of words and symbols, and that math has plenty of symbols. The most recognizable symbol is probably this one, the equal sign. But the word equal is more of a name than a meaning. A good direct translation of the equal sign would be is the same as, which is a phrase rather than a word. But that's okay. Translations don't have to be a one-word to one-word correspondence. This English 8-word sentence is 6 words in Polish, but 10 words in Albanian. Math is just much more concise. It takes fewer symbols to contain a meaning, except you don't find a mathematics option in Google Translate. So what gives? Is it a language or not? I don't think we can judge by Google Translate. It only has 103 languages, and there are over 6,900 spoken languages currently in use, not to mention all the dead languages. My point is that Google Translate is far from complete. So let's try a translation on our own. Math uses the Latin letters and the Greek letters, both uppercase and lowercase, and a whole collection of other unique symbols, which is probably why people are so afraid of it. All of those symbols have at least one meaning, but many have multiple meanings that we have to understand by context. For example, an uppercase B could be the bulk elastic constant, which represents how rigid something is in response to pressure changes, like air in response to a sound wave passing through it. But an uppercase B could also be the strength of a magnetic field, the kind of thing you might imagine is around a bar magnet. This is pretty typical of languages, though. Take the English word duck, for example. It could refer to a type of bird, or the action of suddenly lowering your head. Words with multiple meanings are so common, there's a word to describe them. Homonym. So multiple meanings doesn't disqualify math as a language either. Let's try to translate a whole sentence. Say you've got a simple mathematical sentence like this. It makes use of 6 symbols. Delta, S, equals, F, I, and minus. We've already seen equals means is the same as. Delta means change in, and S means position, or where something is. The F and I are only subscripts. They just describe the symbol they're attached to, so they're more like adjectives than nouns. F stands for final, or at the end. I stands for initial, or at the beginning. And minus means the difference between. So this mathematical sentence reads, the change in where something is the same as the difference between where that something is at the end and where that something is at the beginning. Seems like a pretty logical statement to me. You can do this with other mathematical sentences too. Newton's second law, Ohm's law, even Einstein's equation. Like any other translation though, you lose some meaning. Mathematical sentences say a lot more than their English translation. You're also going to have a really hard time translating the other way. This English sentence has no translation in math. Although I'm willing to hear arguments in favor of this one. Translations, grammar, adjectives, and nouns sounds a lot like a language to me. And as a scientist, I use it to communicate with people all the time. So is math a language? I would argue yes. And just like any other language, it's governed by a set of rules. Those rules are just a lot more absolute than a typical language, and they're built from the ground up. This gives math some extra power if you know how to use it. Which brings us back to our original question. Is math really the language of the universe? Okay, this one's a little trickier. If math really is the language of the universe, then anything we calculate should have meaning, which seems to be true of counting. We take something like this and call it 1, and something like this and call it 2. We can put them together and call that 3. We can put 3 of those 3's together and call it 9. These seem like pretty solid rules, and they seem like they apply to the universe. But we're going to learn a lot more if we try to disprove it. We need to find a number that doesn't have any meaning. There are tons of calculations I could just make up, but no one would ever expect those to have any meaning. Maybe something people would expect to have meaning? What about density? Oh, that's brilliant! I'm so glad you're a clone of me. Density measures the compactness of a substance. An easy way to calculate it is to take the mass and divide it by the volume. And this tells you something about the spacing between the molecules. It makes sense for things like ice, or rubber, or helium gas, or air. Wait a minute. Density measures the compactness of a substance. Air is a mixture of a bunch of different things. Mostly nitrogen and oxygen, but still, a mixture. It's a pretty uniform mixture though, so I can understand arguments in favor of calling it one substance. But what about this? Can't I just measure mass on a scale and volume using a beaker, and then divide the two numbers? I suppose you could, but that number wouldn't really say anything. It's what we call an average density, which might make sense for a uniform mixture like air, but not for this rubber ducky. It's made of two substances, rubber and air, and they're definitely not uniform throughout the ducky. So while it might be a useful shortcut in a calculation somewhere, it doesn't actually tell you anything about the compactness of that ducky. It's a number that only exists on paper. It has no physical meaning, and that's another reason it can't be used to explain why things float. Commenters! Anyway, all average values sit in this gray area. Sometimes they have meaning, and sometimes they don't. Meaning is what we're looking for in science. We're trying to understand deep philosophical questions about our existence, like, where did we come from? Why are we here? Science is about meaning. It's about language. Plus, there are plenty of statements that have meaning, but don't have a translation into math. Math alone will never be enough. No number will ever answer those deep philosophical questions. Not even 42. Math is not the language of the universe. Even if we wanted to personify the universe and say it's trying to communicate with a language, which I would advise against, math would only be a small part of our best translation of it. So what do you think? Does the universe work using math, or is it something we made up? I'd like to know in the comments. Thanks for liking and sharing this video. Don't forget to subscribe if you'd like to keep up with us. And until next time, remember, it's okay to be a little crazy. In the last video, we learned about the lives of stars. Comment response time! Benbedra mentioned that you can learn a lot more from a star's light than just its color and its age. Yes, using optics, we can also learn what a star is made of and how fast it's moving toward or away from us. You can also get distance. Sometimes. But that's a topic for another video. Ira Sanborn told his kids that the light coming from the sun peaks in green. It's pretty weird, but it's true. In fact, it's very common for stars. If you take all the peak wavelengths from all of the stars in the universe, you get a greenish color. It just doesn't look green because it's emitting the other colors too. When our eyes receive light of all colors, it still has to send that signal to our brain. But that looks like a jumbled mess. So your brain turns it all white to create contrast in your field of view. Yeah, white is an illusion. Also a topic for another video. Miss Physics wished she had studied more astrophysics in her undergrad. The downside to university programs is really all the non-majors courses you have to take to get a degree. Undergrad took me 5 years, and I still didn't take all the undergrad physics courses I should have. I guess we'll just have to learn things on our own. It's more fun that way anyway. School's intense. Graham Wilson asked if black holes were frozen at absolute zero, and the answer is no. For a while, we had these special laws for black holes, but eventually we realized that they're just the laws of thermodynamics. Black holes have to obey the laws of thermodynamics just like anything else, even though that might result in a few paradoxes. Future video. I agree with Jim Groth that how we know what we know is very important. Getting to see the process can make science feel more doable to non-scientists. And learning the history behind it can help us understand the obstacles we ran into along the way. Which is why my advanced ebook is written from a historical perspective. Because even people who go into physics like me need that history. Keyed in mode, Star Trek is the best reason to talk about Wolf 359. A close second would be that it's so low mass that it almost isn't a star. Future video. Okay, one more thing before I go. YouTube has started these end card annotations that work on mobile, but there's a 20-second time limit, which means that I can't use them. These comment responses are a few minutes long. I'm considering separating the comment responses into their own video, kind of like how Idea Channel does it, but I didn't want to do that without talking to you first. Pros, it lets me use the mobile annotations and it makes the videos a little more shareable. Con, it separates the conversation, which I'm really hesitant about. Let me know your thoughts or feelings about this in the comments. Okay, crazies, thanks for watching. I'll see you next time.